because that's pretty standard. Alright, the other thing about chemistry is that very often we're very scared. If it says 3 drops, you count 1. The 3. I understand. Okay. So on the one hand, if you worked in a place like I did where precision is very important, we have to be very careful on exactly how much we use. For this demo, I'm not going to be too stressed about how much I use, which is bad. Okay? But I want to show you that one can, if you accidentally have too much of this or too much of that, it just means that there are extra reactants still around in our reaction. Okay? It's not that the reaction is not going to work. You get it slightly wrong. So I'm going to use, let's say, 1 spatula full, half a teaspoon of, can you see I'm measuring with a teaspoon? Like a good chemist. Also have my lab coat on, and my glasses, and my gloves. Then, okay, so we've got these 2 acids. Now we need to add our sulfuric acid, and I'm going to add about 5 to 7 drops in each of them. Sulfuric acid is nasty, okay? So I am not a fan of it. Okay? Waste those up immediately. And now we're going to add, let's do our ethanol. No, this is surgical alcohol. So we'll add about 10 moles. As you can see, I'm using my measuring cylinder. Alright. And what does happen is that our salicylic acid will start to dissolve in this, and we're going to heat it. You use a test tube, you can put it in the water and heat it up a bit. You might need to leave that for a little while. Another blend here. Right. Lab assistance also useful. And now we need to add our methanol. Now, ideally with methanol or these big containers, you actually pour it out into a smaller container before you pour it into that. Okay. That's just the color is liquid and another color is liquid, right? So let's keep this color this stuff. But the white powder, it starts to dissolve. Starting to dissolve too much. And it might close, what is happening, maybe you can see it, at the top, my crystals are starting to crystallize out. Okay. It's a product of correction. Now, some of the people at the back say, oh, it smells strong. It is quite strong. An important thing of doing crack work is that some smells you will remember. If you walk into a place and say, oh, it smells like hospital. What does a hospital smell like? What does a swimming pool smell like? Swimming pools. Alright? We connect certain smell with certain things. Alright? And that helps our memory. There's something you learn with visual, but smell is definitely a strong thing as well. Okay. Maybe that's yours dissolve. Yes. Ooh, ja. Can you pass it along? Now, what we're going to do is I'm going to carry on, and then later we'll come back to this. We'll take it out of the water, out of the heat, and then it'll cool down. And it should crystallize out. Okay? Should. Right. Louisa's passing that along, and you can smell. Tell me what you think you smell. It's quite strong. Now, some learners will say, okay, yeah, it smells like whatever, but what if that just is the same as what we started with? So what is useful is to get them to smell the starting product, and then the final product, and then can detect that actually this one is now different. Why is it different? Well, something else must have formed. The other important thing is that we've only added ethanol in that case, salicylic acid, and sulfuric acid. We haven't introduced anything else. So whatever we get can only be formed from those products. Okay, important concept. You can only manipulate the number of carbons you have to get your product. Okay, we can't introduce new things. Right.